Hello everyone. In this video, we shall discuss an introduction about conic sections, and then afterwards, we shall focus on the discussion about circles. Now let's define first what is a conic section. A conic section is an intersection of a plane with a right circular cylinder. So in the right side of this slide, we can see that there are four right circular cylinders, and each of them are intersected with a plane. So in the upper right or upper left corner, we see that the plane intersects the cylinder and it forms a parabola. At the upper right corner, we see that the plane and the cylinder intersects and forms a circle. And then at the lower right corner, the intersection of the plane and the cylinder is an ellipse, while at the lower right corner, the intersection of the cylinder and the plane is a hyperbola. Hence, we have four conic sections, namely the parabola, the circle, the ellipse, and the hyperbola. Now, the conic sections have the following general form of equation. The equations of conic sections are second degree equations in two variables x and y. So we see that it is a second degree equation because its highest exponent is 2. So now the general form is a times x squared plus b times xy plus c times y squared plus d times x plus e times y plus f is equal to 0. Now the coefficients a, b, c, d, e, and f are all real numbers. However, at least one of a, b, and c is not non-zero or not zero. Now the shapes of the corresponding graphs of the equation depend on the values of these constants. However, for our discussion, we shall only consider conic sections where b is equal to 0. That means we don't have the term b times x times y. Therefore, a conic section having the following form, a times x squared plus c times y squared plus d times x plus e times y plus f equals 0, will be the focus of our discussion. So given the general equation of a conic section in this form, we can identify that it is a circle whenever a and c are not both 0. And at the same time, the values of a and c are equal. Now, it is a parabola if either a is equal to 0 or c is equal to 0, but not both. So therefore, if the given equation doesn't have an x squared or doesn't have a y squared, then it is a parabola. Now, it is an ellipse if a and c are not equal, but a and c have the same sides, meaning a and c are both positive or a and c are both negative. Now, the conic section is a hyperbola if a and c are not equal and a and c have different sides. So let's have some illustrations. So let's consider the following equations of conic sections, and let's identify the type of conic section that they represent. So the first bullet, we see that the coefficient of x squared is a equals 2, and the coefficient of y squared is c is equal to 2. Now we see that a and c are equal, therefore this is a circle. The second one, we see that the coefficient of x squared is a equals 3, and the coefficient of y squared is c is equal to 27. Now a and c are not the same, but they have the same signs. So meaning this equation represents an ellipse. Now for the third bullet, the coefficient of x squared is a equals 2, and the coefficient of y squared is c is equal to negative 1. Now we see that a and c are not the same, but they have different signs. So this equation represents a hyperbola. Now for the last one, we have the coefficient of x squared is a equals 6, while we don't have a y squared term, so which means that c is equal to 0. So if one between a and c is 0, then it means that the conic section represents a parabola. So now, since you already know how to identify the type of conic section given the general equation of a conic section, we can now proceed with the discussion about circles. Now, what's the definition of a circle? A circle is the set of all points in a plane that are equidistant from a fixed point. When we say equidistant, it means that if we get several points on the circle and we compute their distances with a fixed point, all those distances are the same or are fixed. So the fixed point is called the center of the circle, which is denoted by capital C, and we shall denote its coordinates by h and k. And the fixed distance from the center to any point on the circumference of the circle is called the radius of the circle, and it is denoted by small r. So from this definition, if we get, let's say, a point P on the circle, and if we compute its distance from the fixed point or the center, that distance is the radius r. Now, if we get another point Q on the circumference of the circle, and if we compute its distance from the center C, then its distance is still the radius r. Okay, now, so going back to the general equation of the conic section, now we can identify that this represents a circle if A is not 0 and C is not 0, and A and C are the same. However, it would be easier to graph a circle if we know its standard form. The standard form is actually referred to as the center radius form of the equation of a circle. The center radius form is given as follows. So if we have the center, which has coordinates h comma k, and we are given with the radius r, then the standard equation of a circle is given by the quantity of x minus h quantity square plus the quantity of y minus k quantity square is equal to r squared. So once we have this form, we can graph the circle easily. So to graph a circle, we first write it in the standard form. If it is already in standard form, then we can determine its center C and radius r. So once we know its center C, we plot the center C on the Cartesian plane. And then from the center, we move our units upward, our units downward, our units to the left, and our units to the right to plot 4 points that would lie on the circumference of the circle. And then we are going to connect those 4 points to form a circle. So that's how simple not to graph a circle. So let's have an example. Let's consider the equation x plus 2 quantity square plus y minus 1 quantity square is equal to 4. Now, since the standard form of the circle is written as x minus h squared plus y minus k squared equals r squared, we have to make sure that we can write the given equation in this form. Now, this x plus 2 here can be written as x minus negative 2, which indicates that h is equal to negative 2, while y minus 1 is already in the y minus k format, so that means k is equal to 1. So let's write them down. H is equal to negative 2 and k is equal to positive 1. So the center of the circle has coordinates negative 2, comma 1. Now for the radius, since the right-hand side of the equation is 4, then we can just write it as the value 2 quantity squared. So this indicates that the value of the radius r is equal to 2. So since we already have the center and the radius, then we can plot the center. So from the origin, we move 2 units to the left and then 1 unit upward to get this point. Now from this center, we have to move r units upward, r units downward, r units to the left, and r units to the right. So if r is equal to 2, so we have to move 2 units upward, 2 units downward, 2 units to the left, and 2 units to the right to get these 4 points. And then we connect these 4 points with a circular pattern. So that's how simple to graph a circle given its standard form. Now, what if the equation of the circle is in the general form? So how do we graph the circle? So first, we need to write the equation in standard form before we can graph it. So let's consider the circle x squared plus y squared minus 8x plus 12y minus 12 is equal to 0. So this represents a circle because A is equal to positive 1 and C is equal to positive 1. A and C are equal. So in order to write this in standard form, we need to group first all those terms with x, and then we group all those terms with y. And then the constant, negative 12, will be transposed to the right-hand side. It will become positive 12. And then each of the groupings here, the shall, in each of the groupings here, we shall add a, particular constant. Now we can determine that constant by using the completing the square method. So in the completing the square method, we get the coefficient of the middle term. So here, coefficient of x, and then we get also the coefficient of y here. So each of these coefficients will be divided by 2. So negative 8 divided by 2 is equal to negative 4. But we need to square negative 4, which is positive 16. So we have to add plus 16 here. So if we add plus 16 here, and since there's no multiplier outside of the grouping symbol, then we can also add 16 at the right-hand side. Now for the second grouping, the coefficient of y is 12. So we have to divide 12 by 2. It's going to be positive 6. And then we square 6, and that's going to be 36. So we have to add 36 here. And since the coefficient of this grouping is just 1, 36 times 1 is 36. So we have to add 36 also at the right-hand side. So writing this, we get x squared minus 8x plus 16 plus the quantity of y squared plus 12y plus 36 is equal to 12 plus 16 plus 36. Now 12 plus 16 is 28. 28 plus 36 is 64. Now, afterwards, we can now factor each of the groupings as a square of a binomial because these terms inside the groupings would form a perfect square trinomial. So for the first grouping, this will be the square of x minus 4. And then the second grouping will be the square of y plus 6, quantity square. And then we have 64. So this is the standard form of the circle. So we can also write this as x minus 4 quantity square plus the quantity of y minus negative 6 quantity square equals 64. So this indicates that h is equal to positive 4 while k is equal to negative 6 and 64 is actually the square of 2. So which means the radius r is 8. So to plot or to graph the circle, we plot the center, which has coordinates 4, negative 6. So in this case, from the origin, we move 4 units to the right and then 6 units downward to get the center. And then from the center, we have to move 8 units upward to get a point on the circle, 8 units downward to get a point on the circle, 8 units to the left, and 8 units to the right. And then we just connect these 4 points by a circular pattern. So that's how we graph a circle and how we write the general form of a circle into its standard form. Now, the next 3 slides would give us problems that requires to find the equation of a circle given certain conditions. So if we are tasked to find the general equation of the circle with center at 3 comma 2 and passing through the point P uh, with coordinates -1 comma -2, we need to write first the standard form of the equation. However, in order to form the standard form, we need to know first the center of the circle. But since it is already given here, there's no problem with that. But we don't have a radius, so we need to find first the radius of this circle. So since the center is 3 comma 2, which is located on this position, and from the given information, the circle passes through the point -1 comma -2. So which means that the circle passes through this point. So that means we can determine the radius if we can find the length of the distance between the center and the point P. So the radius is actually given by the formula or the distance formula. So we have x sub 2 minus x sub 1. So we can probably use this as x sub 2 and this one is x sub 1. So that's -1 minus 3 quantity square, and then plus y sub 2, which is -2, minus y sub 1, which is +2 quantity square. So simplifying further, we get the square root of -1 minus 3 is -4. And when we square it, it becomes +16. And then -2 minus 2 is -4. When we square it, it is also +16. So this gives us square root of 32. And in simplified form, the square root of 32 is actually 4 times square root of 2. So now, to get the standard form of the equation, we have x minus h squared plus y minus k squared is equal to r squared. So the h here is 3 and the k is equal to 2. So we have x minus 3 quantity squared plus y minus 2 quantity squared. And our radius is 4 square root of 2 or square root of 32. So we can just have square root of 32 quantity squared. Okay, and then since we're looking for the general equation of the circle, so we need to expand x minus 3 square and y minus 2 square. So this is going to be x square minus 6x plus 9 plus the quantity of y square minus 4y plus 4. And then square root of 32 quantity square is 32. Oops, I need to erase the square here. Okay, I'm sorry for the error. And then we can write now the equation as x squared, and then we have plus y squared, and then we have minus 6x, and then we have minus 4y. And then we just add 9 added to 4 is 13. And then we transpose 32 to the other side. So it's going to be 13 minus 32, which is -19. And then the right-hand side is 0. So this is the general form of the equation of the circle having the following conditions. Okay, next. Now this time let's find the standard equation of the circle with diameter and points A with coordinates -2, 4 and B with coordinates 3, 1. So diameter means that it is twice of the radius of the circle. So the circle passes through this point A, the circle also passes through this point B. So in order to determine the standard equation, we need to know the center C with coordinates H and K, and we need to determine the radius R. So how do we determine the center? So the center of this circle is represented by its midpoint. So the center is the midpoint of point A and point E. Now, what is the formula of the midpoint of a circle? So if the point A has coordinates x sub 1 comma y sub 1, and the point B has coordinates x sub 2 comma y sub 2, the midpoint of A and B, or the midpoint of the line segment joining A and B, is equal to the formula x sub 1 plus x sub 2 over 2, comma y sub 1 plus y sub 2 over 2. So the center here is now given as negative 2 plus 3 divided by 2, and then 4 plus 1 over 2. So this is equal to the point positive 1 half and comma 5 over 2, or positive 5 over 2. Now for the radius, we can actually get the distance between A and B, and then we just divide it by 2 to get the radius. So if we get the distance of A and B, that's going to be the square root of the x sub 2 minus x sub 1. So that's going to be 3 minus negative 2 quantity square plus 1 minus 4 quantity square. So this can be simplified as the square root of 3 minus negative 2 will be positive 5. And then when we square it, it becomes positive 25. Okay, plus 1 minus 4 is negative 3. And then when we square it, it becomes positive 9. So this is equal to the square root of 34. So the radius r must be equal to square root of 34 divided by 2. So the standard equation of the circle will be x minus h, which is 1 half quantity square, plus y minus k, which is 5 over 2 quantity square, is equal to the square of square root of 34 over 2. So we can write this as x minus 1 half quantity square plus y minus 5 over 2 quantity square. And then the square of square root of 34 over 2 will be 34 over 4, which can be simplified as 17 over 2. So this is the standard equation of the circle having the following conditions. And then finally, let's determine the standard equation of the circle with center C having coordinates negative 1 comma negative 4 and tangent to the y-axis. So if we can plot the center on the Cartesian plane, this is the point negative 1 comma negative 4. And then according to the given information, the circle is tangent to the y-axis. So which means that it's tangent at this particular point. So obviously, if the circle is passing through this point on the y-axis, that means that the radius r is the distance of this center and this point here. And that's going to be 1. That's only 1 unit. So r is equal to 1. So which means if we are going to use the standard equation of the circle, x minus h squared plus y minus k squared equals r squared. Since we already have the center, that's going to be x minus negative 1 quantity squared plus y minus negative 4 quantity squared is equal to the value of r, which is 1 quantity squared. So this is x plus 1 quantity squared plus y plus 4 quantity squared equals 1 squared, which is 1. So this is the standard equation of the circle having the following conditions. So this ends our video about introduction to conic sections and our discussion of circles. So I hope that you learned something from this video, and please do not forget to subscribe to my channel. Thank you for listening.